Welcome everybody to today's talk. My name is Sebastian. I'm the manager of the Application Competence Center team at Nexperia. And today I would like to give you the answer Nexperia has on this question called what is the next generation application, what are the requirements in terms of high voltage, high power components. Before I start with the actual presentation, let me just briefly show you the topics I've prepared for you. First of all, obviously, I will start with a brief introduction and then dive into the fragmented landscape that we see, especially in electric vehicles. And what is the implication in terms of portfolio for Nexperia? That's something I will discuss afterwards. And then I will conclude the talk with some in-application verification examples and how we use these results to optimize our products and conclude the talk with a summary. Okay, so introduction. I think we have discussed it many times already, all these mega trends that we see, electrification, fossil fuel reduction. What we see is really a trend towards more electricity. We now want to generate more heat also with electricity. So this means really, especially in the domain of 600 volt devices and above, a massive ramp up in terms of power semiconductors. The question now is for a semiconductor company how to supply the market. So what is the right product? Especially when we think about that there is silicon solutions, but also gallium nitride and silicon carbide now ready to go. And what I've prepared for you is just on a high level, on a superficial level here, an overview that the requirements our customers have are very different. What we see is that, for example, in white goods, obviously price performance is one of the key priorities for them. While, for example, in server power supply farms, in data centers, etc., if you need power supplies there, it's obviously that efficiency is extremely relevant for them to achieve because of the total cost of ownership. And on the other hand, onboard chargers, for example, it's that mass in the car. When you run the car, so usually power density is extremely relevant for them. So it has massive implication on what kind of semiconductor is required in terms of characteristics and material. But there are also other factors. We call them the strategic factors of our customers. So just to name a few, assembly strategy. The assembly strategy of our customers determine what is really their product that they can use. You can have the best product, but if you have it in the wrong package, you will not sell it. So that's something we have to consider as a semiconductor company to supply the market. And also the purchasing strategy is relevant to know. Of course, there are customers that permanently request the same device, although it might be that another device is better, just to ramp up the volume and have a better position in terms of negotiation. And also, especially now with silicon carbide and gallium nitride available, supply security, second and multi-sourcing is very relevant. All these things, besides also the design efforts, traded with benefits, and of course quality of material, all these have impact what kind of semiconductor they consider. And that's the challenge for a semiconductor company to supply the market with the right products. The question is now, is there already, it seems to be extremely fragmented in the market. Is there any harmonization that we can see already? So for that, I would like to dive into electric vehicles to show you how the situation is currently there. Yeah, and I answered the question already here. It's fragmented. I want to tell you why. When we see electric vehicles that now replace combustion engine vehicles, we have a lot of new converters in the car. And when we try to summarize the requirements, what kind of power levels are required, what kinds of switching frequencies the different applications switch usually, what we can immediately see is we have massive different switching frequencies, from single-digit switching frequencies up to megahertz in the car. We have soft switching applications like in an onboard charger, DC-DC converter, hard switching, even resistive switching sometimes when we have high voltage heaters. So obviously, when we just look into the car, heavily fragmented power levels and conversion principles that we face, and that leads definitely to different power semiconductor requirements. So there is not a one-fits-all solution, obviously. But is there at least in one of those segments a harmonization that we can say it will be this or that technology. So for that, let's have a look into the onboard charger. Key application, I would say, at the moment in the car. And we look here, it's superficial, but I think I made my point. We have a lot of different mission profiles that we see. Different power levels, up to 22 kilowatts of power. Some of the onboard chargers have to operate in bidirectional full mode. Some just rely on a unidirectional power flow. 400 and 800 volt batteries, so there is a lot of different variations out there. And it's also in the next generation what we expect. So the question is now, is there at least, I think you might my point, I get deeper and deeper from top to bottom. And we just look here. Is it here at least harmonized in terms of power semiconductors in the three-phase PFC setup? But you can see already multiple topologies can do the job. And I tried to cluster them here. You see 650 volts with this bluish color and orange 1200. Various topologies can do the job. And all of those I've recently seen in request for the next generation onboard chargers, start of production, let's say 2027 or so. So basically it says you cannot rely just on a 1200 volt solution or a 650 volt solution. As a supplier, you have to ultimately offer various of those semiconductors and various technologies from silicon over silicon carbide to gallium nitride, because of the mission profiles are so different. And the reason for that in the onboard charger is especially that the topologies that we currently see are heavily fragmented. A lot of those topologies can do the job. What happens if we just briefly jump to traction inverters? In traction inverters, it's different. The power, the topology usually is harmonized. We see usually just three-phase inverters. Multi-levels, I would say, in the early development phase, but at the moment, the major request you receive is classical for three-phase inverters. But the power levels the customers request, the packaging, and therefore what the semiconductor they need is heavily different. And I just also dig briefly into that. What are the key factors here which influence the choice of the customer to choose a specific semiconductor technology? It's obviously that there is currently not a harmonization in battery voltage. We see 400 volt batteries, we see 800 volt battery architectures, but also is the semiconductor technology that we can provide, is it ready for parallelization? Is the die size or the die size ratio fitting to the requirements of the customers? All those things make it very complex in terms of the decision. And also they request absolute different technologies from silicon to silicon carbide and gallium nitride. And this decision usually is influenced in terms of what is the car profile. And thanks to the dissertation of Dr. Pai, he made a very good analysis in terms of what is the distribution of current when a module of, in this particular case, a 450 amp power module, when it is used in the city mission profile in the car. And what we can see is that the majority of the time, the car runs just under low load conditions. And especially if we think about then IGBT characteristics, we are running in a case usually which is not, let's say, the most suitable one for IGBTs. So that means this can motivate customers to make the move in traction from silicon away to silicon carbide or gallium nitride, or to combine it with different dual motor concepts, etc. And not to forget, how is the deliverable? What is the customer expecting? Many different deliverables we see. From bare die, that you want to do their model on their own because of their supply chain strategy, also to standard modules, customized one, up to transferred mold, modular approaches. Everything is at the moment available in the market, and at the moment I don't see a trend that it harmonizes. Yeah, and then we just talked about EV. Theoretically, but we are not having that much time, unfortunately. We can theoretically analyze all those other segments as well on that level. And we can immediately see it must be fragmented, and it is fragmented at the moment. So the question is, how can Nexperia supply the market? So what we see and what we have is a multi-dimensional problem. We have the problem that we have to think about what is the right semiconductor technology that we want to offer, combine it with the right power rating, and not to forget the package, but that's something I will discuss several slides later. This combination already is very complex to decide for a company. What is the right strategy? An Nexperia strategy looks like this. We have a solid foundation in silicon, and we will enlarge, and we are already enlarging our portfolio in terms of voltage for silicon up to 1200 volts. We will offer IGBT solution, medium speed with short circuit ruggedness, rated short circuit, and high speed variants as well to fill the gap to wide bandgap devices. And also we will supply the market with classical diodes in ultra-fast and hyper-fast configuration. So we are talking about trading, conduction, and switching loss here. We'll also offer, as indicated here in the bubble, silicon carbide up to 1200 volts as an immersed pin Schottky structure configuration, as well as MOSFETs, something we can discuss in detail at the booth regarding the details, because we're running out of time, unfortunately. And also gallium nitride is something that we already offer in both configurations, E-mode and cascode. I'm not aware of another company that offers simultaneously both technologies at the moment at the market. So just here an indication that where we see this greenish check mark, this is something we released already. So cascode E-mode is already released, merge pin Schottky diodes released, and IGBTs and MOSFETs are coming soon. When I talk about coming soon, I mean within this year. Okay, so another problem is what is the right package? I already indicated it. Many different topologies, many different solutions out there. What is Nexperia's answer to this question? We will start with the wide span of technologies. The classical, I would say the classical TOs expanded from real 2-pin and 3-pin classical options, TO247-3, up to maximized creepage 4-pinners and plus packages to maximize the power dissipation, especially for higher current products. But we will complement our portfolio also with SMD parts. So classical also here, we start from the classical parts, already released some of those by the way, with 3-pinners to increased creepage devices with real 2-pin, up to more and more complex solutions, up to what one of my former colleagues already announced, by the way, also for a topside cooled high voltage SMD part, something we will release in the next couple of months. Additionally, we will also offer for the wide bandgap content bare dies in different deliverable forms, up to modules. Up to some just to show you some examples. There is more to come, but currently nothing that I can reveal so far. But you see that we mean it really serious. From classical to very customized solution, everything is on our roadmap. So what I'm telling you more or less is that we do a diversification, a very broad approach to address the market and to supply it because of the high fragmentation that we see. Okay. Next chapter is in application verification. This is all power semiconductors above 600 volt applications. These applications are heavily depending on application feedback to really optimize the product. And I just want to give you a short insight how we do that. Of course, how do we get the information? It's customer. Do you need solid customer base and customer contact? This is something where Nexperia has a solid base because we are more than 60 years in the market. But we also do our own test from day one when we develop our products in terms of efficiency sweeps, ruggedness tests, switching tests, so all what we call the in-application verification. So from day one, our samples are heavily tested under various conditions to mimic what the customers do with our products and what they plan to do. And we use this as, of course, an optimization to target to our goal to offer best-in-class products with outstanding quality, and of course we want to offer very good customer support to help them for design-in activities. Just to give you some examples, of course, by the way, something that we have at our booth, this board, double pulse board, classical evaluation boards. We start with this classical test to see how our devices are performing under various conditions and various commutation loop inductances, etc. But also we want to understand the thermal performance as well, not only to characterize RTH junction case, really what is the thermal stack, what kind of impact it has, what kind of power can really be dissipated, very closely to what customers are doing. But also, just to give you another example, parallelization, where the challenges in parallelization versus different package options here. Another example, topside cooled option, paralleled 5 in parallel. So where the challenges there, tilt is a challenge, gap filler, choose those things to really maximize the power, and also not to forget the electrical parameters to have the maximum symmetry in terms of dynamic performance as well. But we also do classical in-application verification in converters to really understand how our devices perform. And here we can see we have a very good result here and there, but we are lagging a little bit here. That means for us, as this back and forth, if we want to enter this with this product, we need to optimize it or at least enlarge the portfolio in this regard to be also there in a leading position. And we do that also, by the way, also a demonstrator that we have at our booth in various solutions, buck boost converter in this particular case, but also in soft switching options to really understand how our devices perform under various stress conditions. And not to forget, just briefly want to mention it, not to forget short circuit and ruggedness, in-rush situations, all those things we do from day one with our products. You can see that we do it until we destroy the device, or when we analyze how high is the temperature during an IFSM-like event, or when we mimic even more realistic searches. All those things we club together and maximize and optimize the product. So that brings me to the last slide already. The question, what is the next generation application? What can we expect in terms of power semiconductors? It's definitely fragmented, and it will stay fragmented for a longer time. There's, at the moment, not really a harmonization visible. I really personally expect even more fragmentation in terms of technology, in terms of packages, especially with the maturity of silicon carbide and gallium nitride. This is really, customers are spoiled for choice in that regard, and we have to answer it with, to supply the market on a broad basis. That's what Nexperia is going to do. We offer a wide span of packages, from the classical through-hole technology up to customized solutions, and even up to later, then, as I already said, topside cooled SMD options as well. Yeah, but this was just a scratch on the surface. If you want to discuss these things in more detail, I can now just tell you, come to our booth. We are at Hall 9, 317. There we can discuss, as I said, much more details about all those products and the product lineup and timings, etc. Yeah, that was the last slide. I can just tell you, it's the beginning of PCIM. Enjoy the PCIM, and hope to see you all at our booth. Thank you very much.